All right, so just keep pushing on with chapter 1. This section is one of the, I guess, harder sections in chapter 1. It's factoring trinomials again, which means we have 3 terms. That's not new. But what makes this section different is there's going to be a number in front of the squared term, or the first term, that you can't factor out as a GCF. And just like the last section, grouping can be used to solve these problems. And just like the last section, there's another method that might be a little bit quicker and a little bit easier than grouping that can be used. So the first 18 problems I'm going to do by grouping, and then I'll teach the new method or another method, and there's multiple methods that you can use other than grouping to factor when you have 3 terms, a trinomial with some number in front of the x squared term. And the one I teach is called bottoms up, more or less because it's kind of easy to teach, it's easy-ish to learn, and they teach it at Sandra Day in Mountain Ridge, so a lot of students already have seen this. So grouping is a little bit different when we have a number in front of the x squared term. In the last section, I would have just written down factors of 6 and tried to turn that 6 into a 13 essentially. In grouping, when there's a number in front of the x squared term, I need a different first step. So when there is a number in front of the first term, I need to multiply the first and last numbers without the x. So I'm going to multiply this 5 and this 6. So again, this is anytime there's a number in front of the x squared term, I can't just look at the last number to turn the last number into a middle number. I have to look at a product should be more consistent with what I did last time. So I'm going to do just like I did for grouping in the last section. I have my target number. I'm going to write down the factors of that target number. So 1 times 30 is 30. 2 times 15 is 30. 3 times 10 is 30. And leave enough room. 5 times 6 is 30. So I could break up into 1x plus 30x, 2x plus 15x, 3x plus 10x, or 5x plus 6x. And I need the pair that's going to give me the 13x, and that's the third pair. So I'm going to rewrite this problem from 3 terms to 4 terms, and that's what you do for grouping. You need 4 terms to factor by grouping, and I'm going to write a 3x and a 10x. So I'm going to leave this at 5x squared plus 3x plus 10x plus 6. It would have been okay, and I'd get exactly the same parentheses, just in a different order, had I written 5x squared plus 10x plus 3x plus 6. Doesn't matter the order that you put the terms with the x's, you just need the right 2. And the reason these are the right 2 are the numbers 3 and 10 multiplied to 30 and 3x plus 10x add to 13x. Now I'm going to factor by grouping, so I'm going to get my two parentheses. I'm going to make a 5x squared plus 3x and a plus 10x plus 6. First parentheses, there's a common factor of an x I'm going to factor out. When I take an x away from the first piece, I'm left with a 5x. From the 3x, when I take an x away, I'm left with a 3. Bring down my plus sign. I better get a 5x plus 3 inside the parentheses, and I will. I'm going to factor out a 2 from the second parentheses. When I factor out a 2, I have to divide by 2, and that's going to leave me a 5x plus 3. I'm just about ready to write my answer. For my answer, I'm going to factor out that common factor of 5x plus 3, and I'm going to leave behind an x plus 2. I can completely check this. I'm done, but checking is never a bad idea. To check, I'm going to FOIL my answer. So my firsts are 5x times x, which is 5x squared. My outers are 5x times 2, which is a plus 10x. My inners in my checking are 3 times x, which is a plus 3x. My lasts in my checking are 3 times 2, which is a plus 6. I'm going to combine the outers and the inners and get 5x squared plus 13x plus 6, which, because it's exactly the same as the original problem, I know I have the right answer. The nice thing about grouping is that it's consistent. It's the same for problems from section 1.3 and as it is for problems from section 1.4, other than you have the first step that's a little bit different. The alternate method to bypass grouping, it's not the same from section 1.3 to 1.4, and this could be why some students will just factor by grouping forever. And in both sections, in section 1.3 as well as section 1.4, you only need to learn one of the two methods that I teach, and if whichever one you get comfortable with, you can use. I'm going to leave myself a lot of room for number 4, but I'll try to squeeze it in here. First step, I'm going to multiply this times that, and 5 times 6 is going to give me 30. So in my table, I'm going to write down not factors of 6, but factors of 30. And I need to get negative signs in there. I need two numbers that multiply to be positive 30. So with some negative signs, so negative 1 and negative 30 will work. Negative 2 and negative 15 will work. Negative 3 and negative 10 will work. And negative 5 and negative 6 will work. Which allows me to potentially rewrite the 13x as minus 1x minus 30x, or minus 2x minus 15x. That's the tricky one that doesn't work. Minus 3x minus 10x, or minus 5x and minus 6x. Now I'm going to combine these. And because the numbers have the same signs, I add the numbers and keep them negative. So I'm going to get minus 31x, minus 17x, minus 13x, and minus 11x. That means this is the pair that I need. And so I'm going to rewrite my problem with a minus 3x and a minus 10x. So I'm going to go 5x squared minus 3x minus 10x plus 6. Now I'm going to factor by grouping. I'm going to make this a 5x squared minus 3x and a minus 10x plus 6. Get that minus sign inside the parentheses so I can factor out the minus. First set, there's just a common factor of x. When I factor out an x, I'm left with a 5x minus 3. Second, there's a common factor of 2, but I need to drag this negative out, so I'm going to put a negative 2 up front. And even without thinking, I know my parentheses have to match, so I'm just going to write that parentheses down. But I could have went, negative 10x that was inside the parentheses divided by the negative 2 that I factored out would give me a 5x first. and a positive 6 that was inside the parentheses divided by the negative 2 that I factored out would give me a negative 3 second. It's not a coincidence that the parentheses are the same. Now I'm ready to write down my answer. Both on either side, there's a 5x minus 3. That's a common factor that I could factor out. Now I'm going to be left with an x and a minus 2. Again, I could FOIL that, and that would FOIL out to be exactly the original problem. For problem 6, I'm going to start off multiplying the 4 and the 3. So the difference in the grouping method when there's a number in front of the square term is you have to multiply first. So now I'm going to hunt down factors of 12. The nice thing is there's no negatives, so I need the positive factors. So 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. And the ways that I could break up to get that middle term would be 1x plus 12x, 2x plus 6x, 3x plus 4x, and when I combine, see how I'm kind of shifting up the names that I'm writing on the top of the columns, because they really don't matter. I can write whatever I want on the top of the columns just as long as I know, if they tell me what I need to know to do. So in this setting, and I messed up, I should have been using y's. I should have written 1y plus 12y is 13y. I should have wrote 2y plus 6y is 8y, and 3y plus 4y is 7y. You really should stick with the letter that's in the problem. A lot of times on tests, students will change a y to an x, and I can't ever remember taking a point off for that. If you get the kind of everything right and you accidentally switch the letter because we're so used to using x, it's not such a big deal. So I'm going to use 1y and 12y and make this 4y squared plus 1y plus 12y plus 3, and then I'm going to get my parentheses in, 4y squared plus 1y plus 12y plus 3. First parentheses, again, there's just a common factor of a y. When I factor out a y, I'm left with a 4y plus 1. Second parentheses, there's a common factor of a 3, and I better get another 4y plus 1 because the parentheses have to be the same. Now, there's a common factor of 4y plus 1 that I'm going to write first, and it's going to leave me with a y plus 3. It's always optional, but you always can check. So I'm going to check this real quick to make sure I haven't messed up. I'll go firsts are 4y times y, which is 4y squared. Outers are 4y times 3, which are plus 12y. Inners are 1 times y, which is plus 1y. Lasts are 1 times 3, which is plus 3. Those give me the 13y that I need to. I'm going to combine the outers and the inners and bring down the firsts and the lasts. When I look at the result of my foiling my answer compared to the original problem, because they're exactly the same, my answer is correct. That's the only time I know my answer is right when I'm factoring a trinomial, is if after I FOIL it out, I get exactly the original problem. For 8, I need to multiply the 4 and the 3 and get 12. And so I'm going to start writing down my factors of 12. And I need to get a negative in there, so I'm going to do the double negatives. I can't do a positive and a negative, because a positive and a negative would only multiply to negative 12. So I'm going to try negative 1 and negative 12, negative 3 and negative 4, negative 2 and negative 6. This would let me break up this into negative 1y minus 12y, negative 3y minus 4y, or negative 2y minus 6y. And when I combine these, because both the numbers have the same signs, I add the numbers and keep them negative. So the top would give me a minus 13y, the middle would give me a minus 7y, and the bottom would give me a minus 8y. It means I need this breakup. So I'm going to rewrite this as 4y squared minus 1y minus 12y plus 3. First grouping, 4y squared minus 1y. Second grouping, minus 12y plus 3. First grouping, there's a common factor of a y, so I'm going to factor out the y. I'm left with 4y minus 1. Second grouping, I had a common factor of a 3, but I need to factor out a negative because the first term is negative. So I know I'm factoring out a negative 3. I have to have another 4y plus minus 1, and I won't even try to think that out. I'll just copy it. As long as you pick the right setting, the numbers, if the numbers do what they need to do, these numbers needed to negative 1 time need to multiply to 12, and the rewrite needs to give me a minus 13y. As long as you get those two things happening, the numbers you pick multiply to the right number, they combine to the right middle term, then the parentheses are going to come out the same and grouping's going to work. So sometimes I try to speed up the process so I am just being efficient. So here my answer is going to be 4y minus 1 and y minus 3. For 10, I'll start off multiplying the 2 times the negative 7, and I get negative 14. So now I need the factors of negative 14, which means there's going to be one positive and one negative. If I'm clever, I won't waste time, but if I'm not clever, I'll waste time. So 1 and 14, 2 and 7 are the factors of 14, and then, like I said, because signs are important, you need to get the negative sign in the right place. And in this case, because I'm trying to get a positive 13, the smaller of the factors needs to have the negative sign. If you would have written down all 4 groupings, the bottom groupings that I have here are never going to give me a positive number, because when one of the numbers has a sign, when you combine to get the last column, the sign will be the sign that has with the larger number. Here the larger numbers are positive, so it's going to combine to be a positive. Here the larger numbers are negative, it's going to combine to be a negative. And I'm wanting to combine to be a positive, so I shouldn't have even considered those. But I could do them all. Negative 1z plus 14z, negative 2z plus 7z, 1z minus z minus 14z, and 2z minus 7z. And when I combine those, they have opposite signs, so I subtract. 14 minus 1 gives me a 13 with a z. 7 minus 2 gives me a 5 with a z. 1 minus 14 gives me a negative 13 with a z. 2 minus 7 gives me a negative 5 with a z. Must be that I need this set there, because there's the 13 that I'm looking for. So I'm going to write 2z squared minus 1z plus 14z minus 7. Make my parentheses. 2z squared minus 1z plus 14z minus 7. Here I'm factoring out just a z. And I'm left with a 2z minus 1. Here I'm going to factor out a 7. I don't factor out a negative because the first thing in the parentheses isn't negative. When I factor out a 7, I have to be left with a 2z minus 1. And then, final step, factor out the 2z minus 1. I'm left with a z plus 7. So the answer should be 2z minus 1 times z plus 7. It's completely optional, but you're more than welcome to check. You check by foiling. If I'm checking by foiling, I'd go firsts are 2z times z, which is 2z squared. I do outers, which is 2z times 7, which is plus 14z. I do inners, which is minus 1 times z, which is minus 1z. Look how I wrote the x when I meant to write z. And lasts, minus 1 times 7 is minus 7. The outers and the inners are 14z minus 1z, basically that, which give me a 13z. So bring down the first, combine the outers and the inners to a 13z, bring down the lasts, and that and this are equal to each other, so I know I have the correct factored answer. 12, I'm going to multiply the first and the last number. 2 times negative 7 is negative 14. So my lasts have to multiply to negative 14, which means they can be 1 and 14 or 2 and 7, but I need to get the signs to work for me. And if I'm being efficient, I know which one needs to get the negative sign, because I'm trying to get a negative in the middle. In order to get a negative in the middle, the negative sign has to go with the bigger number. If you put the negative sign with the smaller number, you're not going to get a negative, you're going to get a positive. So my rewrite could be 1z minus 14z, 2z minus 7z. I shouldn't try these bottom ones because they're going to give me the wrong sign. I know they're not going to work. So I should have only written the top two, but you can be inefficient and still get to the answer. And I forgot to write, there's a minus, I just can't read my writing. So 1 minus 14 gives me negative 13 with the z. 2 minus 7 gives me negative 5 with the z. Negative 1 and positive 14 have opposite signs. I subtract, take the sign of the larger, they give me a positive 13z. Negative 2 and positive 7 give me a positive 5z. I need 1z minus 14z, but I'm going to write minus 14z plus 1z, because if I have my choice, I'd rather, if there's a positive and a negative, I'm going to write the negative first. It makes my factoring easier. You could write 1z minus 14z, then you have to factor out a negative. And if you change it to negative 14z plus 1z, you're not factoring out a negative. So I'm going to rewrite this as 2z squared minus 14z plus 1z minus 7. Make my parentheses, 2z squared, again I wrote the x, minus 14z plus 1z minus 7. First parentheses, common factor of 2z. When I factor out a 2z, I'm left with a z minus 7. Second parentheses, no common factor, so I'm going to say there's a common factor of a 1. And when I factor out a 1, it doesn't change what's inside the parentheses, although I can take the 1 away from a z to make it look like the first parentheses. So I have a z minus 7 left over. Now there's a common factor of z minus 7. When I factor it out, I'm left with a 2z plus 1. That should be my answer. I could FOIL it to check, but I'm not gonna. Ugh. I can't think that I'm pretty sure, I'm not pretty sure what I meant, but I don't think 14 is written properly, because if I multiply 6 times 43, I'm going to get 258, and I would never do that to you. So let me change this to something that I hope works. Yeah, I think I just meant to write 4 here. So I'm going to change problem 14, and when you print it out, it'll already be changed. To 6x squared plus 23x plus 4. Because in the first step, I'm multiplying these numbers. 6 times 4 multiplies into kind of a harmless 24, but 6 times 43 would get out of control. I couldn't have meant that to happen. So I'm not going to factor this problem. I'm going to factor this problem. So I'm going to multiply the 6 and the 4 and get 24. No negatives, so I don't have to worry about any signs. The factors of 24 are 1 times 24. So it's okay. My rewrite is probably not a stellar rewrite, but it's better than the original. 2 times 12. 3 times 8. 4 times 6. I could break that up into 1x plus 24x, or 2x plus 12x, 3x plus 8x, and 4x plus 6x. Now I'm going to combine these, and I'm going to get a 25x, a 14x, an 11x, and a 10x. I don't see the 23x that I'm shooting to get, which means this new one that I made up is prime. It doesn't factor. It could have happened that the original one factored, but I don't think I could do it right now. So I'm just going to say this is prime, and that's okay because it's potential and it's possible to get primes when you're factoring. The way how you can tell when you get primes is you just can't get the combination to give you the correct middle term. So my rewrite, maybe I didn't intend this to be prime all along, but it's okay that it's prime. I'm going to multiply the 5 and the 7. I'm shooting for 35. So I need the factors of 35. And again, this is nice because there aren't any negatives. Factors of 35 that I can think of are 1 and 35, 5 and 7. Don't have any signs to worry about, so I won't throw any signs in. My rewrite can be 1x plus 35x, or 5x plus 7x. When I combine those, I get a 36x or 12x. I want the 12x, so I'm going to do that for my rewrite. I'm going to go 5x squared plus 5x plus 7x plus 7. Introduce my groupings, so 5x squared plus 5x plus 7x plus 7. First set, there's a common factor of 5x. When I factor out a 5x, I'm left with an x first and a plus 1 second. Second parentheses, there's a common factor of a 7. When I factor out a 7, I'm left with an x plus 1. Notice how I'm not really explaining my greatest common factor factoring. At some point, my videos get long enough as it is, and at some point, I hope that you get comfortable with one of the skills, and I'll start to progressively show less and less of that skill, and hopefully that's okay. Now I'm going to factor out the x plus 1 and be left with a 5x plus 7, and that's going to be my answer. Again, I could check this by foiling, but I don't have to if I think I did it right. 18, I start off by multiplying the 6 and the 7 and get a 42. No negatives, so I don't have to worry about any signs. I'm going to do factors of 42, which are 1 and 42, 2 and 21, 3 and 14, 6 and 7. It doesn't matter if I don't know all the factors of 42 as long as I find the right ones. So this would allow me to break it up into 1x plus 42x, or 2x plus 21x, or 3x plus 14x, or 6x plus 7x. That's the pair I'm going to need because those will combine to be the 23x. So I'm going to rewrite this as 6x squared plus 2x plus 21x plus 7. Introduce my parentheses. First pair, there's a common factor of 2x. When I factor out a 2x, I divide the 6 by 2 to get a 3. Take one of the 2x's away there to get an x. Bring down my plus sign. Anytime I factor out something identically, I need to leave a 1 where it was. Bring down my plus sign. Second grouping, there's a common factor of 7, and I have to have the same parentheses left over. Ready for my answer. Common factor of 3x plus 1 leaves me a 2x plus 7 left over. So that's grouping. You could do every problem in this section with grouping. You can factor every trinomial that anyone could ever give you by grouping. The thing about grouping is you're dealing with more variables. It's, it's a little slow, and most students eventually abandon grouping for the other methods that I teach. And that's what we're about to learn now, a new method called bottoms-up method. There's something called guess and check that is how I factor myself, and it involves doing lots of computations in your head. If you're really comfortable working with doing adding, multiplying, subtracting in your head, and you want to learn the guess and check method, I'll come to my office or send me an email. Well, I can teach you this one-on-one, but it's not a good method for the masses, because most students just don't have a just good enough ability to do math in their head for that method to make sense, although it's the method that I use. So we'll look at 19 through 30 first, and all of a sudden they're the same as 1 through 12. So I know the answers to these problems. So problem 1 asked me to factor 5x squared plus 13x plus 6, and I got 5x plus 3 times x plus 2 for an answer. So I know the answer when I get done with this is supposed to be 5x plus 3 times x plus 2, because regardless of the method I use, I'm not going to get different answers. And if I'm factoring 5x squared plus 13x plus 6, I'm either going to get 5x plus 3 times x plus 2, or I'm going to get x plus 2 times 5x plus 3. There's no wiggle room for that. You have to get the same answer, and it'll check the same way. So how do I do this bottoms up method that I say is easier? First step is the same. The first step for bottoms up is the same as the first step for grouping. I'm going to multiply. So this is going to be bottoms up. If you stick with this method through these problems, I think you'll like it better than grouping. The first step in bottoms up is to multiply. And in this case, I'm multiplying the 5 by the 6. What I'm going to do to get my 30 is I'm going to rewrite the problem by stealing the 5 away from the first term and writing that product into the last term. First step was multiply. Done with my first step. Second step, I'm going to factor what's sitting in front of me. So I stole the number from the first term, incorporated it into the 30 in the last term. Now I'm going to factor this. I know my firsts have to be a couple of x's, and my lasts have to multiply to be 30. So I'm going to write factors of 30, which are 1 and 30, 2 and 15, 3 and 10. Those would break up into either 1 plus 30, 2 plus 15, or 3 plus 10. 1 plus 30 is 31, 2 plus 15 is 17, 3 plus 10 is 13. This must be the numbers that go in for my lasts. They're both positive, so I'm going to put a positive 3 and a positive 10. Can't put them in the wrong parentheses because it doesn't matter. If you look at this and this, those aren't the same answers. The answer I'm shooting for is this. The last step's kind of a 3-step in one process. My first step was to multiply the last number by 5. My last step is to divide that number by 5. And my last step's kind of a 3-in-1 step. So 3 part 1 is divide. 3 part 2. Any fraction that's reducible, I'm going to reduce. Specifically, the fraction 10 over 5 reduces to 2. And the last thing I'm going to do is bottoms up. Any fraction that's left, I'm going to take its denominator and write it in the first position. Bottom meaning denominator, up meaning dragging it out of the denominator, moving it up into the first position. When I tuck that 5 in and put it next to the x, I take the 5 away from the 3 and the 3 remains, and the x plus 2 doesn't change when I bottoms up. If you look at these, they're identical. Bottoms up will give me always the same answer as the grouping method if I do them both right. So problem 22 is identical to problem 4. So I know my answer for problem 22. I better get the same answer. My answer for problem 4 was 5x minus 3 times x minus 2. The only wiggle room I have is my answer could come out to be x minus 2 times 5x minus 3. There's no more wiggle room than that. You have to have exactly the same two parentheses. So let me try to get there without grouping, because grouping is a slow method, not so great. So first step is to multiply. So I'm multiplying the first number by the last number. I only can use bottoms up when there's a number in front of the x squared term. If there's not a number in front of the x squared term, I don't need bottoms up. So I multiplied. I'm turning this into x squared minus 13x plus 30. And now I'm going to factor this. For some students, they get baffled by signs, and sometimes I do this just to help students out, because it's nice to know what the signs are supposed to be in the original when you factor, and this is going to be help with signs. So I can predict, based on the original problem, what signs are going to go inside my parentheses. In problem 22, the signs in the original problem, the first sign is minus, the second sign is plus, and when that's the case, when the first sign is minus and the second sign is plus, you get two minus signs. One of my students says, if the second sign is plus, both the signs are the same, and you refer to the first sign. The second problem on this page, 4y squared plus 13y plus 3, it's nothing but pluses. I'd say the signs in the original problem are plus and plus, and when the signs in any problem are nothing but pluses, you have no choice but to put pluses in your answer. There's no room for minuses. So that's these situations. There's two more situations that I'll talk about as they come up. So this problem, because the signs are minus first and plus second, then my signs in my parentheses are going to be minus and minus. Again, if the second sign in a problem is plus, the signs in the parentheses are two of the same sign, and you refer to the first sign. And that works for this problem. Second sign is plus. I need two identical signs. I refer to the first sign, which is minus. Here, the second sign is plus. I need two of the same signs. I refer to the first sign, which is a couple of pluses. So I know that when I go to factor this, I'm going to get a couple of minuses. And for a lot of students, that's a lifesaver, just to get the signs down first and not have to worry about signs. First aren't so hard. I'm just going to split the x's into x squared into a couple of x's. So now for my multiplying, I need to write the factors of 30. Of course, I need to have double minuses. So I'm going to do minus 1 times minus 30, minus 2 times minus 15, minus 3 times minus 10. That would give me minus 1 minus 30, which is a minus 31, or a minus 2 and a minus 15, which is a minus 17, or a minus 3 and a minus 10, which is a minus 13. Must need this. Again, when the signs are the same, you're adding the numbers and keeping them negative. So I'm going to put a minus 3 and a minus 10 in. And this factors. This equals to the problem above it. Doesn't equal to my answer, either version of my answer. That's because I haven't finished up. So I multiplied first. The second step in bottom up is factoring. And the third step is divide, reduce, and bottoms up. So I started off multiplying by 5, must mean I need to divide by 5. The thing that I multiplied was the last number. I need to divide the last number. First fraction doesn't reduce. If a fraction doesn't reduce, you bottoms up it. And that's going to give me 5x minus 3. Second fraction does reduce. 10 over 5 reduces to 2, so I'm just going to write x minus 2. If I look at this compared to the answer that I got for problem 4, they're identical because I did it right. The answer for problem 24 has to be the answer to problem 6 because they're the same problem. And the answer I got for 6 is 4y plus 1 times y plus 3. So when I go to write my answer down, it better be the case that I either get 4y plus 1 times y plus 3, or it would be okay if I happen to get y plus 3 times 4y plus 1. That's as much wiggle room as I have. I have to get the same parentheses because grouping and bottoms up have to give the same answers. Grouping is kind of the same other than the first step, you know, when you have a number in front of the x squared term. But bottoms up I only use when there's a number in front of the first term. So first step in bottoms up is to multiply. The multiply step, I multiply the first number 4 by the last number 3, and that's going to pick me up a 12. Now I'm going to factor this. And I know for certain that a problem that only has pluses is only going to factor into a couple of pluses. So I can put my signs in, and I can put my firsts in. So I know that factoring this, there's not a number in front of the y squareds. My firsts are going to be a couple of y's. I'm going to split the y squared between the two parentheses. And my signs are going to be plus and plus, come from the template, or they come from the fact that if a problem doesn't have any minus signs, there's no need for minus signs in my parentheses. Now I'm going to figure out what my lasts are going to be. So I'm going to look at the factors of 12. 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. I'm going to add these factors now. 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7. Well, I need to get a 13, so I must need those for my lasts. So a plus 1 and a plus 12. Done with the second step. First step was to multiply. Second step was to factor. Third step is a 3 in 1 step. It's divide. I started off multiplying the last number by 4. I'm going to end up dividing the last number by 4. Any fraction that's reducible, I'm going to reduce. Any fraction that's not reducible, I'm going to bottoms up. First fraction isn't reducible, so I'm going to bottoms up and get a 4y plus 1. Second fraction, 12 over 4 reduces to 3, so I'm going to get a y plus 3. If I look at my answer to problem 6 and the answer that I got to this, they're exactly the same because bottoms up doesn't give different answers from grouping. Grouping and bottoms up have to give the same answer. Same problems only factor with the same parentheses. (26) is the same as 8. 4y squared minus 13y plus 3. So my answer has to be either 4y minus 1 times y minus 3 or y minus 3 times 4y minus 1. I have to have those two parentheses. Grouping took me that much work, and for me it's just harder because I'm dealing with all the letters here. I don't have to deal with the letters. So bottoms up. Bottoms up you only use when there's a number in front of the squared term that you can't factor out as a common factor. Step 1 for bottoms up is to multiply. And I multiply this 4 and this 3, I'm going to get y squared minus 13y plus 12. That's just multiplying 4 times 3. Now I go to my template. I need to factor this. And this again is the first row of my template. The signs in this problem are minus first and plus second, so each of my parentheses is going to have a minus sign. So when I go to factor this, it's not so hard for me to know the firsts are a couple of y's. I need to split that y squared between the two parentheses. But in addition, my template gives me the signs, which means when I go to write my factors here, I do double minuses. So my choices would be to factor this a minus 1 times a minus 12, or a minus 2 times a minus 6, or a minus 3 times a minus 4. If I go minus 1, minus 12, those both have the same signs. Those will give me a minus 13. A minus 2 and a minus 6 have the same signs. Those would combine to be a minus 8. A minus 3 and a minus 4 would combine to be a minus 7. I need the top pair, minus 1 and minus 12. So in one parentheses I get a minus 1, the other parentheses I get a minus 12. Almost done. Now I need to do the last step, which is kind of 3 and 1, divide, reduce, and bottoms up. I started off multiplying by 4, I need to divide by 4. First one doesn't reduce, so I'm going to bottoms up. Second one does reduce, it reduces to 3. If I look at that, and I look at my answer to problem 26, they're the same. It has to happen. 28 and 10 are the same. Yep, and the answer to 10 is 2z minus 1 times z plus 7. So I better get, for an answer, 2z minus 1 times z plus 7. Go through my steps and get a new level of my template for my signs. So first I multiply, and I'm going to multiply this 2 by that 7. Keep that sign in there. So this is going to give me z squared plus 13z minus 14. Now I'm going to go to factor this. And when I go to factor this, I don't have this templated yet. If the second sign is minus, you get one of each sign. If the second sign is plus, you get 2 of the same sign. You refer to the first sign. If the second sign is minus, which it is here, you get one of each. So in this problem, the first sign is plus, the second sign is minus. That's this situation. When I go to factor it, one of my parentheses is going to have a plus sign, one is going to have a minus sign. So when I go to factor this, I know that my firsts are a couple of z's, and I know my sign is 1 plus and 1 minus. And when I write down the factors of 14, I need 1 plus and 1 minus, which would be 1 and negative 14. If I'm inefficient, I could say negative 1 and positive 14, or 2 and negative 7, or negative 2 and positive 7. I need the one that's going to give me a positive 13. Top one, 1 minus 14, gives me a negative 13. The second one, negative 1 plus 14, gives me a positive 13. This is the pair that I need, and I know the 1 has to go with the negative. The 14, because it's positive, needs to go with the positive. So I'm done with the hard part. Now I'm going to divide, reduce, and bottoms up. I started off multiplying by 2. I need to end up dividing by 2. First parentheses, it divides. It becomes z plus 7. Second parentheses, I bottoms up. I get 2z minus 1. And this is the only variation that's acceptable in my answer. If I look at my answer to problem 28 and my answer to problem, I think that was 10, they're not exactly the same, but they're the same enough. They have the same parentheses, they're just in a shuffled order. Did I get any of these? Good. So let me do 30. Again, 30 is the same as, I'm trying to find it, but it's, 30 is the same as 12. So the answer to 12 was 2z minus 7 times 2z plus 1. So that better be my answer to this, regardless if I use bottoms up or if I use grouping, should get the same answer. Bottoms up we only use when there's a number in front of the squared term that you can't factor out as a common factor. So in my efforts to get to this answer, bottoms up requires first for me to multiply, and I'm going to multiply this 2 and this minus 7. I'm going to get z squared minus 13z minus 14. This is my last template. This is the last variation of signs I can have. So in this one, the signs in my original problem that I'm trying to factor are a minus first and a minus second. And anytime the second sign is minus, you get one of each parentheses. So my template's going to be the same, plus and minus. So the second sign is plus, you get two identical parentheses, you refer to the first time sign. So the second sign is minus, you get one plus and one minus. So when I go to factor this, I'm going to get one plus and one minus. And I know my firsts are a couple of z's. So I'm going to make this a z plus and a z minus. And the numbers I'm going to need to multiply to negative 14, so they could be either 1 and negative 14, negative 1 and positive 14, 2 and negative 7, or negative 2 and 7. I can see the pair immediately because this 1 minus 14 gives me the negative 13. I don't even need to check the other ones. I'm going to put a plus 1 and a minus 14 in for my second step. I don't see the same thing as my, I can't read that. This is 2z plus 1 and z minus 7. So now I need to do the divide, reduce, and bottoms up. I started off multiplying by 2. I'm going to end up dividing by 2. First fraction doesn't reduce, so I bottoms up the 2 and get 2z plus 1. Next fraction does reduce. I'm going to get a z minus 7. If I look at that, and I look at the answer to, I think that was problem 12, they're the same enough. They're the same parentheses in a different order. I'm going to change problem 32 because there's one little twist to bottoms up that we haven't seen yet, and we might as well see it. And let me so I'm going to change this. And when you print this out, this will look different. So let me try to think of a good twist. How about 10x squared plus 23, oh, it's getting too big. Hold on. 10x squared plus 19x plus 6. That's a nice, here's the little variation, and the variation is going to come on the divide reduce part. So I made this nice because there's no minuses, so I don't have to worry about getting minuses. First step is to multiply. I'm going to multiply the 10 and the 6 and get a 60. And that's going to give me x squared plus 19x plus 60. One of the big flaws to grouping in bottoms up is that this number can get big and hard to find the factors of. So now I'm going to factor this. And I know my first have to be a couple of x's because there's not a number in front of the x squared term. And when there's no minuses in a problem, my signs have to be plus and plus. Now I'm going to write the factors of 60. 1 times 60 is 60. 2 times 30 is 60. 3 times 20 is 60. 4 times 15 is 60. 5 times 12 is 60. And 6 times 10 is 60. This is going to be the part that just humbles you if you don't know your times tables well enough to spit these out. You don't need to know every pair of numbers that multiply out to be 60, but you need to know the one that works. And that's this 4 and this 15, because 4 plus 15 gives me this 19 that I'm looking for. So in one parentheses, I'm going to get a 4. The other parentheses, I'm going to get a 15. Done with my second step. Here's the twist on my third step. My third step is to divide, reduce, and bottoms up. Sometimes both the fractions reduce and stay fractions, and that's what happens here. I started off multiplying by 10 when I get rid of this problem, so I have to end up dividing by 10. And neither fraction goes away, but I still have to reduce them. The first fraction reduces by 2, and you get x plus 2/5. The second fraction reduces by 5, and I get x plus 15 divided by 5 is 3, 10 divided by 5 is 2. So I get that, and I'm going to bottoms up both of them. So when the fractions don't go away, you'll have a double bottoms up to do, but you have to reduce the fraction before you bottoms up. I think this is the answer. I better check this because I haven't. So I'm going to check 5x plus 2 times 2x plus 3. FOIL it. The firsts are 5x times 2x, which is 10x squared. The outers are 5x times 3, which is a plus 15x. The inners are 2 times 2x, which is a plus 4x. The lasts are 2 times 3, which is a plus 6. I'm going to combine those together. The 10x squared is going to stay 10x squared. 15x plus 4x is 19x, and the plus 6 stays the plus 6. That's exactly the same as the original. So my new problem 32, which will be there when you print it out, it does what I wanted it to do. It has double reducing, double bottoms upping. All right, moving on to 34, and I don't think 34 is like any of the problems. That's just a whole newbie problem as near as I can tell. So I'll treat it as a newbie. And first I'm going to do multiply. So anytime there's a number in front of the squared term, you can use bottoms up. First step is to multiply. Multiply this 3 and this 8. And I get w squared minus 14w plus 24. My template tells me if the first sign is minus, the second sign is plus, I need a double minus. And that's the case here. So I can fill in when I go to factor this. I know my firsts are a couple w's, my signs are a couple of minuses. So I've multiplied, and now I'm factoring. I'm going to get a w minus and a w minus. Now write the factors of 24. I'm going to write minus 1 times minus 24, minus 2 times minus 12, minus 3 times minus 8, minus 4 times minus 6. I'm trying to get a minus 14. These will give me that. Minus 2 minus 12 give me a minus 14. So under one, I'm going to put a 2, and the other I'm going to put a 12, because that's the pair that I needed. They did what they needed to do. They multiplied to positive 24. They added to negative 14. And now I'm into my divide, reduce, bottoms up. I started off multiplying by 3. I need to divide by 3. First parentheses, I just bottoms up and get 3w minus 2. Second parentheses, I reduce and get w minus 4. And I'm done. Problem 36, first step is to multiply. So I'm going to multiply this 8 and 5 and get y squared minus 6y minus 40. Templated, this is this. The signs are minus and minus, so I need 1 plus and 1 minus. Anytime the second sign in the problem is minus, you get one of each. So that's the multiply part. Now I'm into the factor part. I'm going to get a y plus and a y minus, and I need factors of 40, so I can do 1 and negative 40, negative 1 and 40. I'm being inefficient here, but it's okay. 2 and negative 20, or negative 2 and positive 20, negative 4 and 10, or 4 and negative 10. I think I have it already. Once I get to it, I usually don't, I stop. It's the 4 and negative 10, because 4 minus 10 gives me a negative 6. So in one parentheses, I get a plus 4. The other parentheses, I get a minus 10. And now I'm going to the divide, reduce, bottoms up. I started off multiplying by 8. I need to end up dividing by 8. This is another case where both fractions reduce. So I'm going to double reduce, double bottoms up. First fraction reduces to 1/2. Reduce it by 4. Second fraction you reduce by 2, and it reduces to minus 5/4. Now I'm going to get my answer by bottoming up each of these. My answer is going to be 2y plus 1 and 4y minus 5. Of course, you could have written 4y minus 5, then 2y plus 1. That wouldn't, you have that kind of flexibility. $38, same thing. I'm doing bottoms up, so I'm going to multiply first. Multiply this 4 and that 15. I go x squared plus 4x minus 60. My signs, because this is a plus first and a minus second, a plus first and a minus second, you get one plus and one minus. So when I go to factor this, because it's multiply and then factor, I know my firsts are going to be a couple of x's. My signs are a plus and a minus. For 60, I can go 1 times minus 60, minus 1 times 60, 2 times minus 30, minus 2 times 30, 3 times minus 20, minus 3 times 20. Really? Wow. 4 times minus 15, minus 4 times 15, 6 times minus 10, minus 6 times 10. Finally got there. I do math pretty nice in my head, and I was getting worried that I wasn't going to find the pair. I'm trying to get a positive 4. This minus 6 and plus 10 will give me the positive 4 that I need. So my lasts have to be a plus 10 and a minus 6. I already had the signs in. I almost tried to write that minus there twice. So it took me a heck of a lot of work, and I do this fast. So the problem with bottoms up or even grouping is finding those lasts can be really hard. Now I'm going to divide. I started off multiplying by 4. I'm going to divide by 4. And I'm going to reduce now. First fraction reduces to 5 over 2. Second fraction reduces to 3 over 2. And now I'm going to bottoms up, and I'll have my answer. So it's going to be 2x plus 5 times 2x minus 3. That works. 40. First step, multiply. I'm going to multiply this 8 and that 3 and get y squared minus 5y minus 24. Template for that. The signs are minus and minus, so I know I need a plus and a minus. So when I go to factor this, I get a y plus and a y minus. I need the factors of 24. I can go 1 times negative 24, negative 1 times positive 24, 2 times negative 12, negative 2 times 12, 3 times negative 8. I'm there because this will give me 3 minus 8, which is a negative 5. That's what I'm going to put in. Once I find the pair, I stop. I don't need to write every pair of numbers that multiply out to 24. And quite honestly, I don't write any. I just do them all in my head. This is just to show you a process that will get you to the work answer. So I need a positive 3 and a minus 8 to get my minus 5. I started off multiplying by 8. I need to divide by 8. First fraction doesn't reduce, so I'm going to make that an 8y plus 3. Second fraction reduces, and you get y minus 1. And there's my answer for 40. 42 and 44. Nice double pluses, so I don't have to worry about signs. There are a couple of pluses. For 42, I start off multiplying and get x squared plus x plus 21. Now I need to factor this. I know I'm going to get an x plus and an x plus. My last have to multiply to be 21, which are either 1 times 21 and 3 times 7. But they need to add up to 1 because there's a 1 in front of the x. And the 1 plus 21 adds up to 23. The 3 plus 7 adds up to 10. When I get to my second step of my bottoms up, if it doesn't factor, then the whole thing is prime. And I've, in some sense, wasted time. So my answer to problem 42 is there just aren't any pairs that are going to do what they need to do. So this whole thing is prime, and I wouldn't even show any of this work. You don't have to show any of this work, but I just stopped. Once I get to the point where I can't factor what needs to be factored, the whole thing is considered prime. 44 is going to be prime too, I think. 44, I'll multiply the 3 and the 8 and get 24. So that makes me have to factor x squared plus 7x plus 24. I know this will be an x plus and an x plus. Signs have to be plus and plus when there's no minuses. Split the x's up. My numbers for lasts have to multiply to 24. They could be 1 and 24. That adds to 25. That can't be good. 2 and 12, and 2 plus 12 is 14. They're not good. 3 times 8 and 3 plus 8 is 11. That's not giving me the 7. And 4 and 6, which adds to 10. That's not giving me the 7. I can't find a pair of numbers to complete this factoring. and it makes the whole thing prime. So the next group of problems are a little bit trickier, and it exposes a flaw in bottoms up. And the big flaw in bottoms up is if the problem has a common factor and you don't factor out the greatest common factor, bottoms up gives you the wrong answer. And that's huge, huge flaw with bottoms up. That gets exposed in problems 45 through 64. So it's hugely important. If you don't catch the common factor, you'll get the wrong answer. So it is crucial to factor out any GCF first when you use bottoms up. The GCF will be part of the answer, but won't be part of the bottoms up part. If you don't factor out a GCF, you'll get the wrong answer. If you don't factor out the GCF and you use bottoms up, your answer will be wrong. The thing about grouping, if you don't catch a common factor and you use grouping, it still gives you the right answer. That's the only advantage I think that grouping has over bottoms up. So each of the problems between 45 and 64, they have a common factor. You've got to yank that common factor out first. And in problem 46, I think the common factor is a 3, because 15, 36, and 21 are all divisible by 3. So I'm going to go 3, and then factor out a 3, and be left with 5n squared plus 12n plus 7. So now I'm going to ignore, and focus only on that. The 3, that's the common factor, is going to be part of my answer, but it's not going to be part of the bottoms up work. So I'm just going to focus on factoring what you can see, hopefully. And I'm going to multiply this. I'm going to use bottoms up, because anytime you have a number in front of the square term, you can use bottoms up, as long as you get the common factor dealt with. And then I'm going to factor this. This is a double plus, so I know my parentheses are going to be double plus. My lasts can be either 1 and 35 or 5 and 7. They must have to be 5 and 7, because 1 and 35 don't give me the 12. So signs are a double plus. Lasts are 5 and 7. So I've done the multiply, the factor part. Now I'm going to do the divide, reduce, and bottoms up part. I start off multiplying by 5. I'll end up dividing by 5, which will give me an n plus 1 and a 5n plus 7. It would be wrong if I said that was my answer. I need to take that common factor and write it part of my answer. I'll show you how to check this, just because we should check if we feel the desire. So to check this, it's a little messier. To check this, I have to multiply the 3 into the parentheses that it's next to. So I'm going to go 3 times n and 3 times 1. And when I do that, I'm done multiplying with the 3. I get a 3n plus 3. And now I'm going to FOIL. Firsts are 3n times 5n, which is 15n squared. Outers are 3n times 7, which is a plus 21n. Inners are 3 times 5n, which is a plus 15n. Lasts are 3 times 7, which is a plus 21. The 21 and 15n give me the 36n that I needed to have. So this gives me 15n squared plus 36n plus 21, which is exactly the original problem, so I know my answer is right. Again, if I would have done this without factoring out the 3, not only would bottoms up give me the wrong answer, but I would have had to multiply 15 times 21, and I would have gotten 315. There's no way I'm going to ask you to find factors of 315. I mean, 60 is pushing it in terms of a size. No way I'd make you hunt down factors of 315. So just realize in the last group of problems, and any problem that on the test that you want to use bottoms up, if there's a common factor, you have to factor it out first, or bottoms up will steer you wrong. In problem 48, there's a common factor of just an x, because each of the terms has an x. So I'm going to factor out that x. That x is going to be part of my answer, but it's not going to be part of the bottoms up. So again, I'm going to ignore the common factor. I'm going to ignore the original problem. I'm going to go to factor that. And to factor that, I'm going to use bottoms up. I'm going to multiply first. I'm going to multiply the 8 and the 5 and get x squared minus 22x plus 40. I know the signs are a double minus, because if the first sign is minus, the second sign is plus, I get a double minus. So when I go to factor this, I'm going to get an x and a minus, an x and a minus. And the factors of 40 I have to consider are minus 1 and minus 40, minus 2 and minus 20, minus 4 and minus 10, minus 5 and minus 8. The pair that's going to give me the minus 22 are the minus 2 and the minus 20. So after one of the minus signs, I get a 2. After another one of the minus signs, I get a 20. So I've done the multiply in the factor part. Now I'm going to the divide, reduce, and bottoms up. I'm going to divide, because I multiplied by 8, I'm going to divide by 8. Both fractions are going to reduce. The first fraction reduces to 1/4. The second fraction reduces by 4, I think to 5 halves. Now I'm going to bottoms up and get a 4x minus 1 and a 2x minus 5. That common factor needs to be part of my answer. I don't need it to do the bottoms up, but I certainly can't leave it out of my answer. I imagine this is getting long again, and this is kind of a messy one to check, so I'm going to hold off on the checking, but I'll check something before the video ends. Problem 50, each of the terms has a y, each of the numbers is divisible by 3. I'm going to factor out the common factor of 3y. I'll divide 18 by 3 and get a 6, take one of the 3 y's away, be left with a y squared, bring down my minus, divide 39 by 3 and get 13, take one of the y's away and be left with a y. From the 6y, I'll divide it by 3 and take the y away and be left with a 2. Again, now I'm going to factor what's in the parentheses using bottoms up. I'm going to ignore the original problem. I'm going to ignore the common factor. I'm going to put the common factor back in my answer. To bottoms up this, I start off by multiplying. I get y squared minus 13y plus 12. That's a double minus. So when I go to factor this, I get a y minus and a y minus. And my choices are minus 1 and minus 12, minus 2 and minus 6, minus 3 and minus 4. The one that gives me the minus 13 are the minus 1 and the minus 12. So next to one of the minus signs, I need a 1. Next to the other minus sign, I need a minus 12. I started off multiplying by 6. I'm going to divide by 6. First parentheses, I just bottoms up. Second parentheses, this reduces to 2. I'm going to bring this 3y, and that'll be my answer. So I could write the common factor all the way down. Certainly nothing wrong with doing that, but it does, at some point you need to incorporate it in your answer. So if you would have kept the 3y there and it didn't confuse you, be completely fine to do. It's just that some students, they start to do things with the common factor that they aren't supposed to do. How far do we go with this? It goes all the way to 64, which means we have a few more problems to deal with. Problem 52, only is there a common factor of 2, I need to factor out a negative because the first term is negative. I'll go ahead and check this when I get it done. So anytime I'm using bottoms up, I use bottoms up when there's a number in front of the square term, have to pull out a common factor. I'm going to factor out a negative 2. It's going to leave me with a 10x squared minus 9x and a plus 2. When you factor out a negative, it flips the signs. Again, now I'm going to ignore this. I'm going to factor what's in the parentheses by bottoms up, which means I multiply first, get x squared minus 9x plus 20. My template tells me this is a double minus. I know I split the x between the parentheses. I have a choice of minus 1 and minus 20, minus 2 and minus 10, minus 4 and minus 5. There's the pair that give me the minus 9. So I'm going to put down a minus 4 and a minus 5. Not done because I haven't did the divide, reduce, bottoms up. So I did the multiply. I did the factor. Now I need to do divide, reduce, and bottoms up. I started off multiplying by 10. I'm going to divide by 10. Both fractions are going to reduce. This reduces to minus 2/5. Second one reduces to minus 1/2. That's the reduced part after my divide. Then bottoms up, 5x minus 2. Bottoms up, 2x minus 1. Take that common factor in there, and that should be my answer. So go ahead and check that. So to check, it means I have to FOIL, but I need to deal with the common factor first. So checking is completely optional, but if I wanted to check this because I was worried I was making a mistake, the first thing I'm going to do is multiply the negative 2 in the parentheses that it's next to. So I'm going to go negative 2 times 5x and negative 2 times negative 2. That's going to give me negative 10x plus 4. And I'm done now with that negative 2. I'm going to go to FOILing. For FOILing, my firsts are going to be minus 10x times 2x, which is minus 20x squared. My outers are minus 10x times minus 1, which is a positive 10x. My inners are 4 times 2x, which is a positive 8x. And my lasts are 4 times minus 1, which is a minus 4. The outers and the inners are 10x plus 8x, which gives me an 18x. The first stays unchanged. The outers and the inners combine, and the last are the minus 4. That's exactly the original problem, so I know my answer is correct. That's the only way you can know when you factor that you have a correct answer. If you take your factored answer, multiply it out, it has to equal the original problem. 54, there's a common factor of 2. I'm going to factor out a 2. Be left with an 8x squared minus 6x minus 5. Now I'm going to ignore this, ignore the 2, and I'm going to bottoms up what's inside the parentheses. And for bottoms up, first thing I do is multiply. I'm going to multiply that 8 and that 5 and get x squared minus 6x minus 40. Then I'm going to factor this. My template tells me if the signs in the original problem are minus and minus, I get 1 plus and 1 minus. So when I go to factor this, I'm going to get an x plus and an x minus. And my choices are 1 times negative 40. That's not even close. I won't even try the other one. 2 times negative 20. That's not close to a 6. I won't worry about it. 5 times negative 12. That's not good. 6 times negative 10, that will give me a negative 6. So I'm going to put a positive 6 and a negative 10. That's the factor part. Now I'm going to do the divide part. I started off multiplying by 8. I'm going to divide by 8. Then I'm going to do the reduce part. The first fraction reduces by 2 to 3/4. The second fraction reduces by 2 to 5/4, I think. Yeah, now bottoms up, and I get 4x plus 3 times 4x minus 5. That wouldn't be the right answer because I've ignored the common factor. The answer needs to contain that common factor, so my answer is going to be 2 times 4x plus 3 times 4x minus 5. That would check too. Things take a while to check, and I know the video is getting long, so I'm kind of holding off on doing a lot of checking here. So I have 1, 2, 3, 4, 5 problems left, so that should be about 10 more minutes. You got to sit through this. 56, common factor of an x and a 2. I'm going to factor out a 2x. going to take an x away, divide all the numbers by 2. I'm going to get 8x squared minus 6x minus 5. Oh, if I'm ultra clever, I'd realize that problem 54 and 56, they're not the same because they have a different common factor. But look at this. In problem 56 and in problem 54, the next step was the factor 8x squared minus 6x minus 5. I know what that factors into because I just did it. If I was to do problem 56 all full out, I would have done this full steps again. I don't need to do those steps again. I know what this is going to equal to, and I'll go ahead and check this then. I claim that this is the right answer because 8x squared minus 6x minus 5 factors into 4x plus 5 times 4x minus 5. Just a coincidence. I happen to know all that factors because I just factored it. Let me check this just so you can see that this answer works. So this is what I claim to be my answer. To check this, I'll go 2x times 4x, so this is the checking part, and 2x times 3, and get 8x squared plus 6x, and then now 4x minus 5. Now I'll go into foiling. First our 8x squared times 4x. Really? I'm slightly worried because I'm getting 32. 4x plus 3, 4x minus 5. Yeah. Did I make a mistake? I'm getting perplexed here, so give me a second. 16x. I think I have a mistake in problem 54. I know I have a mistake in problem 54. 6 and 10. 6 divided by 2. 8 divided by 2. Oh, no. 10. Oh, no. 16x squared. I have a mistake in problem 54. And I can't see my mistake in problem 54. So I'm going to redo problem 54. Hopefully you found my mistake for me and you were screaming at the computer that, hey, I can't get what you're getting. I can't see what I did wrong, to be honest with you, and that happens a lot. So what I discovered, I was trying to check problem 56 and I was getting 32x cubed. I needed to get 16x cubed. So I screwed something up. I just don't know what I messed up. So I have to redo problem 54. So 54 is wrong. I don't know why it's wrong, but it is. I can't see my mistake. But 54 asked me to factor 16x squared minus 12x minus 10. And I believe my answer is not right. So I'm going to factor out my common factor of 2. When I factor out a 2, I'm left with 8x squared minus 6x minus 5. Quite honestly, I just don't see my mistake. I'm sorry about that. Now I'm going to ignore this, ignore that, bottoms up this. I'm going to multiply and get x squared minus 6x minus 40. Seems to be exactly what I had before. The last are still 6 and negative 10, because no, they're not. Ha ha. I'm supposed to write numbers that multiply out to be 40, and for whatever reason, 5 and 12 and 6 and 10 multiply out to be 60. I should have written 40 is 1 times 40, 2 times 20, 4 times 10. For whatever reason, I wrote 6 times 10, which multiplies to be 60. The last that I'm going to need are a positive 4 and a negative 10. Because positive 4 times negative 10 gives me the negative 40. Those add to a negative 6. So I should have written x plus 4 times x minus 10. Completely sorry about that, but that completely can happen. That you just, do something that's wrong, and it just happens. So I'm going to finish up the bottoms up. I started off multiplying by 8. I'm going to divide by 8. And this is going to give me x plus 1/2 times x minus 5/4 when I reduce. When I bottoms up, I get 2x plus 1 and 4x minus 5. My answer to problem 54 should be 2 times 2x plus 1 times 4x minus 5. I'm going to check this because I'm not confident in myself now. For checking, first I go 2 times 2x and 2 times 1, and I get 4x plus 2, and now I'm going to FOIL. First are 4x times 4x, which is 16x squared. Outers are 4x times minus 5, which is minus 20x. Inners are 2 times 4x, which is plus 8x. Lasts are 2 times negative 5, which is negative 10. This gives me 16x squared. Those give me a minus 12x and a minus 10. Perfect. Now I can redo 56, and I can still be cute. I can take the factoring of 8x squared minus 6x minus 5 that I did in problem 54 and use it for problem 56. So not only was 54 wrong, but 56 was setting up to be wrong. So I'm going to do all 56 on another sheet of paper. And so this is going to be 56. 56, there's a common factor of 2x. I'm going to factor out a 2x and be left with an 8x squared minus 6x minus 5. And now that I doubled up, I know 8x squared minus 6x minus 5 factors into 2x plus 1 times 4x minus 5. So my answer should be 2x times 2x plus 1 times 4x minus 5. Since I've already factored this, I didn't need it to factor it again. Better check it again. So let me check. For checking, I'm going to go 2x times 2x and 2x times 1. That will give me 4x squared plus 2x and a 4x minus 5. Now I FOIL. First are 4x squared times 4x, which is 16x cubed. Outers are 4x squared times minus 5, which is a minus 20x squared. Inners are 2x times 4x, which is positive 8x squared. Lasts are 2x times minus 5, which is a minus 10x. The outers and the inners will combine. The 16x cubed comes down. The outers and the inners have opposite signs. You subtract and take the sign of the larger and get a minus 12x squared, and then I bring down the minus 10x. That's the same as the original problem, so I know I've recovered and got 56 right. That's the important thing about checking, because that is how you know whether your answer is right or not. When I left problem 54 and just assumed that I did it right, I guess I was being a bit cocky that I could do the math in my head, but when you get tired, sometimes you just screw up, and that's what I did there. 58, I'm going to factor out a negative and a 2. When I factor out a negative 2, I'll take the negative 16x squared, divide it by negative 2. That's going to leave me a positive 8x squared. To figure out what to put in place of the 12x, I'll take the 12x that was there, divide it by negative 2 will give me a negative 6x. And the positive 10 that was there, when I factor out a negative 2, turns into a negative 5. This is the third problem in a row that I'm asked to factor 8x squared minus 6x minus 5. It's the third problem in a row that I know what it factors into. I believe this is going to be my answer. And again, I'm going to check it just to make sure. Because 8x squared times 6x minus 5 in any context factors into 4x plus 3 times 4x minus 3. Let me check. I'll start off by going negative 2 times 4x and get a negative 8x, and negative 2 times 3 and get a negative 6. And now I'll FOIL. I'll go first our negative 8x times positive 4x, which is minus 32x squared. Negative 8x times negative 5 is positive 40x. Goes to be kidding me. Negative 8x minus 6, 4x minus 5. All right, keep going with this. I'm obviously fatiguing because I'm not seeing the math in my head that I normally see. Inners are negative 6 times 4x, which is negative 24x. Just feel horrible that I can't do math right now. And I guess you probably feel that way sometimes. Let me make sure. I'm seeing a mistake again. I don't know what it is again. Ugh, sorry, completely sorry. 8x squared minus 6x minus 5. Make sure that's... Oh, duh! So the duh part was... I took my bad work and I used it when I should not have used my bad work. So I took all this time to refactor 8x squared minus 6x minus 5 into 2x plus 1 times 4x minus 5 so I could use that 3 times, and I didn't. I completely, well, it was moronic, but it's close enough to moronic. My answer, completely sorry, is supposed to be -2 times what 8x squared minus 6x minus 5 factors into when you factor it right, which is 2x plus 1 times 4x minus 5. Completely, I mean, I feel horrible for making errors, but it's kind of a good thing in some sense, so you can see what I do when I make an error, how my mind starts to work when I try to check and it doesn't work. I need to start searching for my mistake. I completely meant to cross this out so I wouldn't look at it again, but I forgot. Now I'm going to check this. For checking this, I'm going to go -2 times 2x is minus 4x, -2 times -1 is -2. And now I'm going to FOIL this. -4x times +4x is -16x squared. -4x times -5 is +20x. -2 times 4x is -8x. -2 times -5 is +10. The 20x minus 8x gives me a 12x, so I get -16x squared plus 12x plus 10. Sorry about that really bad string of problems, but like I said, there are worse things than, it's better to catch your mistake and learn a strategy to catch your mistake than it is to leave a mistake. So anytime you factor, you can always check by foiling, and it's a good idea, clearly, because that saved me from writing 3 wrong answers in a row. Ugh, maybe I'm so tired now that I should keep checking. Problem 60, there's a common factor of a 3. I'm going to factor out that 3. I'm going to be left with 7x squared plus 1x plus 3. So I'm going to ignore and go to factor that by bottoms up. First step in bottoms up factoring of that 7x squared plus x plus 3 is to go multiply. I'll get x squared plus x plus 21. Then I'm going to factor. I know my signs are double pluses, and my last can either be 1 and 21 or 3 and 7. But 1 and 21 add to 23. 3 and 7 add to 10, trying to find a pair that adds to 1. There's no pair, so 7x squared plus x plus 3 is prime. It can't be broken down into 2 parentheses. I'm not going to write prime for an answer because I was able to common factor something. So my whole answer, I can't get the 2 parentheses like I did for the last few problems. But it wouldn't be right to say something's prime, because if you have a greatest common factor and you can rewrite by factoring out a greatest common factor, the whole problem isn't prime. The prime part of this is the 7x squared plus x plus 3. I can't write that into 2 parentheses, so I can't go further. I can't do the bottoms up part because the bottoms up part doesn't work, but the whole thing isn't prime. I might get 2 more of those if I remember right. The next one, there's a common factor of a y. When I factor out a y, I get an 8y squared minus 5y plus 1. And now I'm going to ignore, and attempt to bottoms up that. So to bottoms up that, I multiply and get y squared minus 5y plus 8. My signs have to be a double minus. That's from the template. And my choices are 1 and 8, or minus 1 and minus 8, and minus 2 and minus 4. Minus 1 and minus 8 give me a minus 9. Minus 2 and minus 4 give me a minus 6. Neither one of those give me the minus 5 that they need to give me. So the parentheses 8y squared minus 5y plus 1 can't be factored into two parentheses because it's prime. So bottoms up doesn't work, so that one parentheses is going to stay one parentheses, but the whole answer isn't prime because I was able to common factor the original problem. So my answer is only going to have a common factor, and now they common factors in the bottoms up. I think 64 is the same thing. And fortunately, it's the last problem. 64, there's a common factor of 2a. I'm going to factor out a 2a, which makes it immediately not prime. I'm left with a 4a squared plus 6a minus 3. And now I'm going to try to factor, so I'm going to ignore, and I'm going to try to factor this by bottoms up. I'm going to multiply and get a squared plus 6a minus 12. My templated signs are plus and minus. I could have a plus 1 and a minus 12, minus 1 and a plus 12, a plus 3 and a minus 4, a minus 3 and a plus 4, a plus 2 and a minus 6, or a minus 2 and a plus 6. These give me 11s, these give me 1s, and these give me 4s. And I need to get a 6, so that also is prime. And so, because this is prime here, I can't get two parentheses, but it'd be wrong to say the whole thing is prime because there was a common factor that I could factor out. Hopefully, I did the last three right. If I didn't, then let me know. And if I started making mistakes way earlier because my mind's just not as crisp as it usually is, let me know, and then I can make some announcements and maybe have to do this whole video again. It's really an unappealing choice to do the whole video again because it's got to be an hour and 45 minutes, but I certainly will if it's all messed up.